Let's have a look at these three very similar questions. Two of them have the same answer, and the third is a little bit different. So this first one, 3 to the power of 2, well, that one's as straightforward as it looks. It means take 3 and multiply it by itself twice. Positive 3 times positive 3 is positive 9. For the second problem, because that negative 3 is in brackets, means that everything about it, the negative and the 3, is raised to the power of 2, is multiplied by itself twice. So we have negative 3 times negative 3. Negative times negative is positive, so we again have positive 9. But for the third example, we don't have brackets around the negative 3. And in fact, we could rewrite this third one as negative 1 times 3, and it's only the 3 that's squared. So the negative 1 isn't affected by the power of 2. So we have negative, and then 3 times 3. So the answer here is negative 9. Let's play with negative exponents. So here's the one we're familiar with, x to the power of negative 1. So we remember that raising a base to a negative exponent means take the reciprocal. So x to the power of negative 1, simply 1 divided by x. Another way to say this is if I take a base and raise it to a negative exponent, it moves the base to the other side of the fraction line. The second example is very similar, except again, it's only the x that's raised to the power of negative 1, and we saw a similar example on the previous slide. The coefficient, the 2, and think of it as being simply raised to the power of 1. So the 2 will stay in the numerator, and the x will move to the denominator. The third example is a little bit different, because now the 2x is in brackets, so we recognize that both the 2 and the x are raised to the power of negative 1. What we're really using here is the property of exponents that tells us that if I have two pieces in brackets, two factors in the brackets or more, raised to an exponent, then both are raised to that same exponent. So if both the 2 and the x are raised to the power of negative 1, both the 2 and the x will move to the denominator. What's different in this question is that the denominator already has a value other than 1, so the 3 will stay in the denominator, and it will be multiplied by 2x. What's left behind in the numerator? There's a 1. We can simplify the denominator here. There's nothing special about writing the 3 and the 2x in two separate brackets. To clarify, I can write this as 3 times 2 times x, means exactly the same thing as the previous line, but in this line it is easier to see that the 3 and the 2 can now be multiplied together, and we end up with 6x. The third example, or the fourth example rather, is relatively straightforward. The 1 stays in the numerator, and x is raised to the power of negative 1, which simply tells me to pick up the base and move it to the other side of the fraction line. So we have 1 times x to the power of positive 1, but we would never write it that way. If we have a coefficient of 1 and an exponent of 1, don't write either of those. So the answer is just x. And for the last example, we're again leveraging the property of exponents that says if we've got a product, a times b raised to an exponent, then both a and b are raised to the exponent. And we'll add in the last rule we looked at, is if we have a quotient raised to an exponent, then once again, both a and b, numerator and denominator, are raised to the exponent. So what's happening here? Well, the 2, the x, and the 3 are all raised to the power of negative 1. So I'll write it on the side here. We could write this as 2 to the power of negative 1, x to the power of negative 1, and 3 to the power of negative 1, which would tell me that the 2 and the x change sides and move to the denominator, and the 3 moves to the numerator. An easier way to think of this is to recognize that everything will move to the other side of the fraction line. And in essence, we just pick up this fraction and flip it. So we end up with 3 divided by 2x. So that's taking care of the negative. Technically, there's still a 1 there, but as we said before, if our exponent is 1, we're not going to bother to write it. So our final answer is 3 divided by 2x.